yesterday we talked about how to find the limits of a graph, okay, and how to find a limit for points. And we said basically you guys have to like just one little switch in your mind as to how we use limits and how we used limit notation before. So in AP, you use limit notation to describe the whole. We used limit notation to describe the behavior around an asymptote. We used limit notation to describe the end behavior of a graph, which will actually come back in a little bit. But now you're talking about what is the physical limit on a graph. So instead of saying things like a graph goes to positive infinity, we would say that the limit does not exist because there's nowhere where it's stopping. It would just continue on to positive infinity. And we said there was 3 cases in which a limit did not exist. One is if you were looking at both sides as approaching an x value, it's approaching a different y. If that happens, the limit does not exist. If my graph is unbounded at a specific x value, then it would not exist. And the third, which is not as common, but it does happen, is that oscillating. So if you get a picture in which it oscillates between 2 values, we would say the limit does not exist, okay? So these are, yesterday we talked about direct substitution. We literally took our x value at the bottom of the limit. So if it said limit x approaches 2, and then we had an f of x next to it, direct substitution said take that 2, plug it in, and see where the limit goes. That was the easiest way. Another way would be to graph your function by hand and then look at the behavior around a certain value. So we did that with like the 1 over x plus 1, right? Like we graphed 1 over x plus 1. We saw where that if you approach -1, it was unbounded, so the limit does not exist. We used the graphing utility or a chart to find the values. That was in the homework too, like as you're approaching this specific x value, what happens to these. Today, we're going to add into this dividing out common factors and rationalizing. Because of something that did happen in the homework yesterday, when you had a function and you plugged your value in from the x, it made it undefined, right? That happened with number 1. If it makes the value undefined, it doesn't necessarily mean that there is no limit. If the value is undefined there, it could mean that there's a hole. So it could mean it's undefined, but it also could mean that there's a hole. And if there's a hole, there is an answer to the limit. So example 1 gives you something like this. The very first thing you're going to do now is see if these can be factored, just like we did with rational functions. So if I look at the numerator here, I want to try to factor it. How would I factor x squared minus 4x plus 3? Good. X minus 3, x minus 1. And then my denominator, how do I factor x squared minus 2x minus 3? Good. X minus 3 and x plus 1. Now I can simplify, and we know that when we do this, what's happening at that point on the graph? There's a hole. So if there's a hole, a limit does exist, and the way we find it is by plugging the value into our new simplified function. So because I'm trying to find the limit as x approaches 3, I'm now going to take 3 and plug them into these x's. I get 3 minus 1 and 3 plus 1, and I'd get 2/4, which is 1/2. And if I had actually graphed this function out, if I had traced my graph, I had looked at as the x was approaching 3 from both sides, it would say undefined at 3, but as I'm getting closer and closer, it would get closer and closer to 1/2 from either side. So step 1 now is factor, and then see if you can simplify, and then take your value and plug. Actually, step 1 would be to see if I can just use direct substitution and plug that in, because that's the easiest. But in most of these cases, when you plug that into the denominator, it's going to give you 0, which would make it undefined. Then you'll have to factor and simplify. Yes. 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 All right. Then we get factoring with 4 terms. And when there's 4 terms, we got to do what? Factor by grouping. So again, initially, I would see if I could plug these in. If it was smaller, probably. I would see if I could plug those in before I factored it, and it would give me a 0 in the denominator, which these are going to. Then I would factor. So I'm going to factor my numerator. From the first set of parentheses, you can take out what? X squared, and I get x plus 3. Second set of parentheses, you can take out? 9. I'm going to take out a -9, right? So the signs match. X plus 3, and I get x plus 3, x squared minus 9, which becomes another x plus 3 and x minus 3. That's my numerator. My denominator, I'm also going to factor by grouping. From the first set, I can take out the x squared, and I get x plus 1. Second set, I can take out the -9, x plus 1. And again, it factors x plus 3, x minus 3. So my denominator is those 3. So now this is my updated function. And what happens here?
There's 2 holes.
There would be a cross, yep, x plus 3 cancels, so there'd be a hole there. X minus 3 cancels, there'd be a hole there. What's left is x plus 3 over x plus 1. And that is where I plug in my negative 3. Negative 3. No, this time it's negative 3. This guy, you're plugging in from here. Yeah. Negative 3 plus 3 over negative 3 plus 1. And I get 0 over negative 2, which is 0. So as it's approaching negative 3, your limit would be 0.
So you would write it and just put equal.
You just put 0 for the limit.
That's it?
Yep.
You don't put as x goes to negative 3 f of x.
Nope, it just wants the limit. So it might give you like the limit as x approaches negative 3 equals, and it would be 0. Or you simply just answer
Can you
0.
write it out, though?
Yeah, it doesn't make it wrong. Yeah.
You still have snowflakes.
I know. Still good? Then we get stuff like this. So you've got a square root, okay? So, and it says find the limit, use the graphing utility to verify your result. But we're going to find the limit algebraically first. So here's what would happen if I actually just took and plugged this in with direct substitution. What's going to happen in the bottom? It's going to be 0. It's going to be undefined. So I can't do it that way. So I have to do it another way. Bella. All right. So if I want to get rid of, and we did this a while back. You did this actually in Algebra 2 honors for sure. And we've maybe done it once or twice in here. But if I wanted to get rid of a square root, normally they're in the bottom. And we want to rationalize them. So if that was in the bottom, how do I get rid of it? You multiply, like we call it the conjugate, which would be the exact same expression. One gets a plus and one gets a minus. Normally, we don't need it out of the numerator. Normally, the problem is the denominator. But if it's going to give me an error, if I plug 0 in, I have to simplify this in some way, and that's what we do. So whether it's in the numerator or the denominator, we're going to multiply by the conjugate. The conjugate is the exact same expression with a change in the sign between them. So if my initial one said the square root of x plus 6 minus 2, I'm going to multiply, and I'm going to multiply both the top and the bottom, but I'm going to multiply by the square root of x plus 6 plus 2. If the original was a plus, I put a minus between them. And whatever you do to the top, you have to do to the bottom.
Would you ever have a square root term and then 2 other terms after? Would it always be like 1?
It's usually 2. Is that what you mean?
Like
There's only a binomial.
Only binomial.
Yeah.
Okay.
I mean, it could that you would need to change the sign on what has a square root, but that won't happen now. So here's what you don't want to do. I'm gonna use the shortcut, which I'll review for the numerator, but in the denominator, I'm gonna leave it not distributed, and I'll show you why. So in the numerator, these are opposite expressions, right? They both have the same first term, they both have the same second term, but one's a plus and one's a minus. So if you think about it, this would be like a multiplying an x plus 5 and an x minus 5. What happens there? X squared minus 25. Good. It produces the difference 2 squares. And the shortcut there is a squared minus b squared. So I'm going to do the same thing where my a is x, the square root of x plus 6, and my b is 2. So what happens when I square the square root of x plus 6? I get x plus 6. And what happens when I square 2? I didn't expect to stump you on that one. 4. And I put a minus between them. So my numerator has now become x plus 2. So I squared the first term. I squared the second term. I put a minus between them. Now in my denominator, if I leave it without distributing, it looks like this. And notice what has happened. What's in the top and the bottom? X plus 2. So I can cancel that out, and I'm left with 1 over the square root of x plus 6 plus 2. And the x plus 2 was the problem when I plugged in negative 2. So I just got rid of it. And now I can plug negative 2 in to my updated equation. 1 over the square root of negative 2 plus 6 plus 2, which becomes 1 over the square root of 4 plus 2, 1 over 2 plus 2, which is 1/4. Now, if you've got your graphing utility, take it out because we're going to look at the graph. Yeah.
You don't have to rationalize the bottom part.
No, you actually are trying to get rid of the bottom part. And by doing so, we multiply by the opposite of whatever, whichever one has the square root in it is what we're trying to multiply by the opposite of.
If the square root was in the bottom,
You would multiply by the bottom. Yeah.
but would you rationalize or multiply?
That is rationalizing. You're always multiplying by the conjugate. It will get rid of the square root. Yep. All right, so in my graphing utility, I typed the original function. All right, in my graphing utility, I type my function, the square root of x plus 6 minus 2 over x plus 2. And then when I hit graph, oh, my window is very weird. Hang on. On the graph, I get this little flattened curve, which is a square root function. There is some curve to it, okay? And it stops at like that, what, negative 1, 2, 3, 4, 5, 6, because that would be a domain restriction. If this was an actual square root function, that this is where it would start or stop, because that would make my domain is restricted. What I want to know is what's happening around negative 2. So if I just go to second. No, I'm going to just trace it. If I go to trace, and I just look at what's happening as my x is approaching negative 2, it's going to skip over it, but I'm going from negative 1.96 to negative 2.12, and my y value went from 0.249 to 0.251. So what got jumped? 0.24, which is 1/4. I mean 0.25, which is 1/4. Does that make sense? Okay.
Couldn't you just solve it from what?
Not from the beginning because it was undefined.
No, I mean from like when you plugged in the.
Oh, yeah. So this said use your graphing utility to verify your result. That's all. Okay. Yep, and you won't have your graphing utility on your quiz, so you'll be doing it algebraically. All right. Another pullback from Algebra 2 is complex fractions. So it says find the limit, use the graphing utility to verify your result. And again, there was a complex fraction in last night's, okay? So hopefully this will help you understand a little bit better. But if I take my 0 and I plug it in, I'm dividing this thing by 0, which makes it undefined. Therein lies the problem with just the direct substitution. So I have to simplify this, okay? There's a couple different methods to simplifying complex fractions. One is finding a least common denominator of all the secondary denominators, which would be x minus 5 and 5, and then multiplying each term by them. This goes back to complex fractions. The other is I can combine my numerator together, so those two separate fractions, I can combine those together, and then I can flip it at the end. I would say if there are only denominators in one part of your fraction, I go with method 2 where you only have to combine those and then flip. If there was something like x over 25 in the bottom and there's another denominator in the bottom, then I do the first method because I get rid of them all in one time. So my least common denominator of my numerator is 5 times x minus 5. So the long way around this is changing them so they have that denominator and then combining them. And by changing them, I mean this one's going to get multiplied. The one's going to get multiplied by 5. And this one's going to get multiplied by x minus 5 because that's what those denominators are missing. So this becomes 5 plus x minus 5 all over 5 times x minus 5. All that is still over x. Then in my numerator, the 5's cancel, and I get x over 5 times x minus 5 divided by x. When we divide by x, we would multiply by 1 over x. And then the x's cancel, and I get 1 over 5 times x minus 5, which can be distributed but doesn't need to be. But what that process just did was eliminate the x from a denominator. So now I can plug in 0. I get 1 over 5 times 0 minus 5. 1 over 5 times negative 5, or negative 1/25. And that's your limit. It just goes back and reviews like stuff from algebra 2. Your radicals, your complex fractions, all that stuff's going to get pulled in. Questions on that one? All right. This one says use a graphing utility to actually not verify, to find your result. Okay. So also this, like if you did this algebraically, this also goes back to algebra 2 honors. You would have to multiply the top and the bottom by the cosine of x plus 1. It's like multiplying by the conjugate to get rid of sine in the bottom, but we're not doing that. It's just saying use the graphing utility to verify your result. So I'm going to go to my graphing utility. I'm going to type that function in. When I graph it, I want to see what's happening at pi over 2, okay? And pi over 2 is literally like 3.14 divided by 2 if you wanted to determine that beforehand so that you can see it on your graph. This is 1.57. So that's what we're looking at, the behavior of my graph around there. So this is what your graph looks like, okay? If I want to know the limit as x approaches 1.57, I'm going to go back to the trace feature. Trace, I'm going to watch the x values. I want to get close to 1.57, but it's going to skip over it because it's going to be undefined there. So I'm going to keep going. Here I went from 1.51 to 1.667, and my y value changed from negative 0.9 to negative 1.1. So what's in the middle of negative 0.9 and negative 1.1? Negative 1. Oh, I don't want to hear myself. So that limit value is negative 1. All right, this one also says graph the function. So do this one. Do this on your calculator. Graph that function and then figure out what happens around 0. Again, we couldn't plug 0 in because it would make it undefined. So graph the function. These questions will show up in your homework, but not on the quiz. Okay. All right, so on this guy, well, this could without you having to graph it. Like maybe if you got that picture, you'd have to be able to answer it, that kind of thing. Yeah. All right, so what's happening this time? There's a vertical asymptote there, so what's happening at 0? What's happening with my values? Without bound, if they're increasing or decreasing without bound, what is the limit? Limit does not exist. So infinity is the behavior of f of x, but we say a limit does not exist because it doesn't stop, right? The limit is where that would stop. Yeah.
So if it's evaluate the end behavior, it'd be to infinity.
Not n, that would, so n behavior, this is not n behavior. N behavior is out. N behavior is as f of x is going to negative infinity and as f of x is going to positive infinity. Is that what you mean?
I mean, like.
So the way, when we did it that way, it was to describe the vertical asymptote using limit notation. And as it's approaching here, f of x is going to negative infinity. As it's approaching here, it's going to positive infinity. That's what you would have used it. But the limit doesn't exist because if it's going to positive infinity or negative infinity, there is no stop. And the stop is where that limit is. Does that make sense?
Yeah.
Okay. All right, last one, and this one you would do by hand. So it says graph the function to find the limit. Use a graphing utility to verify your result. So we're back to piecewise functions. I have two parts. The first says where x is less than 1, I want y to equal 4 minus x. So if I'm going to graph that guy, y equals 4 minus x, what kind of graph is that? It's a line. How do I graph it? I go up 4, I plot a point, and my slope in this case is -1, right? So I'd go down 1 and to the right 1, or up 1 and to the left 1. And my full line, I'm going to eventually reduce this, but my full line would look like this. But this piecewise function says only keep where x is less than 1. So I go to where it equals 1. Oh, I'd have an open dot, sorry, open dot. And I point it left, because that's where x would be less than 1. For that part, yeah, but there's another part to this graph, right? Oh my gosh, it won't let me erase it. Okay. Okay, now I'm going to do this second one. And the second one is what? What kind of graph is that? Quadratic. But it's not in standard form, right? So I can't just shift this around, right? I can take out, yeah. I would have to complete the square to get it into standard form, so we're not going to do that. I can just plug the values in. So if I want to see what happens to my curve where this is restricted, I would start with 1, because 1 is where I want to put a dot. It's going to be an open dot, but I want 1 there. So I do 4 times 1 minus 1 squared. Right, but you need to know what happens there. It just gets an open dot. So I'd get 3. So at 1, my coordinate point is at 3, which is where it already is. It gets an open dot, which it already has. And then I would want to know what's happening to the right of it, technically, if I was graphing this. Already I have enough information to answer this question for the limit. But if I wanted to graph it, I would then plug in, I'm going to go to the right, so I plug in 2. And I get 8 minus 4, which is 4. And at 2, 4, my graph is here. And I actually don't care what's happening beyond this. Like, my graph might do this because it points down, so I know it does that. It could have also just, like, gone down right from there. It doesn't matter. What I need to know is what's happening around the 1. And around the 1, my y value would be what? 3. So the limit of this graph is 3. So not every piecewise function does not exist. It would only be that way if there were 2 different values here. If there were 2 different y's, then I would say does not exist. Even if those different y's, one was solid and one was open, it would not exist. The only time you'd get an answer for a limit on a piecewise function where they're different is if it gave you direction. If it said from the positive side or from the negative side here, then I can answer it. Yep.
Could your limit ever be undefined?
No. It either doesn't exist or it's a value. Yep. Questions?